I ended up missing my next meeting because I had to figure out how long will it take for us to crack the encryption standards that we use for Bitcoin. So if you think of Willow as essentially like one stable, logical qubit equivalent in a chip, we need about 4,000 to break RSA 2048. And we need about 8,000 to break SHA 256, which is the underlying encryption framework for Bitcoin. I think we're in the sort of like
the end game,
2 to 5 year shot clock. No, I mean, I think what'll have to happen is some of these chains will need to obviously re-implement something at a pretty foundational level. The weird thing, as Freeberg says, is like the Willow chip's error correction gets better the more of these things you start to use together. Now, there are some really big problems inside these chips, like logical interconnects are very complicated. If you put two chips on a board, like the C2C communication is all this stuff that we haven't figured out how to do. But this is a big deal. And I was really like, oh my God, what's going on here?
Other projects at Google are finally landing. You have
It's
Waymo,
really incredible.
And you have this now. I mean, Project Loon might be gone, but I think those projects, we're going to see a couple of them change the world. Yeah.
Just to give you a sense on the numbers, like Google's target for fault tolerance on a quantum chip to make it logically useful is 1 × 10⁻⁶. Right now, this Willow chip is kind of running at 99.7%. So it's still a few orders of magnitude away. They have a long way to go in getting the fault tolerance low enough to actually build logical gates using qubits that can resolve kind of computational output. And so there's still a build cycle ahead, and that pathway is a little bit unclear. But what they've shown is this almost feels like the Shockley transistor moment. It's like, here's this this transistor. Now everyone's like,
you have a lossy transistor, and then you'll figure out p-in junctions. You'll figure out all of these ways of just like getting the error correction down. But by the way, this reinforces what you said before, which is it's hard for an outsider like us to comprehend what's really happening inside of Google, because the business they've built was able to fund this. I mean, and I went down a rabbit hole because I'd never heard of who this guy was that runs this, Helmut Nevin.
He's in Santa Barbara. They have a whole team in Santa Barbara. They've been running for like 10 years.
He has his own law, Nevin's Law. And then I went down the rabbit hole of that. But what's amazing is, so valuable for humanity, Google had the money to fund him for the last 12 years.
Exactly.
And
the greatest money printing machine of all time is paying dividends. Yeah.